So in contrast to the covalent compounds, which are made up of two nonmetals, ionic compounds have a couple of different configurations. We can have a binary ionic compound, binary meaning two, made up of only two elements, one metal and one nonmetal. So NaCl, sodium chloride, one metal, one nonmetal. AlCl3, same situation. MgO, again, one metal, one nonmetal. We can also have what are called polyatomic compounds. Polyatomics consist of ions that are more than one element. And I'll explain what that means in a little bit, but calcium carbonate is made up of the calcium metal and the carbonate polyatomic. We would not in any way ever call this calcium carbon oxide or any combination of that. If we were to do that, that would be similar to a covalent naming system, and covalent compounds always have only two elements. Ionic compounds may or may not. So if we look, and this is in the data booklet, it'll be easier to see there because I've had to reduce it for the screen. We have the periodic chart of ions, which is set up very similar to the periodic table, except in each element's case, we have the charge that it forms as an ion and the spelling of its ion. So oxygen, as an ion, has a charge of -2, meaning it's electrically charged. We won't go into a lot of detail about what that means yet. That's more left for Chemistry 30. Potassium, over here, has a charge of plus, which would be considered +1. And we also have this list in the middle. This list is a set of what are called polyatomic ions, ions that consist of more than one element. The common ones I've put in bold for you so that when we're dealing with this, easy to find. Most of them are alphabetical. But if we take a look at something like carbonate, carbonate is CO3 2-. It consists of one unit that is CO3. So when we come down to naming these ionic compounds, it's actually very simple. We name the first ion and we name the second ion. If the second ion is out of the periodic table, we change the ending to IDE. If it's out of the polyatomics, the ending is already there. As you can see, we have lots of ATEs, some ITEs, and so on. The complication comes with some of these ions that have more than one possible charge. If we take a look at nickel here, because of nickel's placement on the periodic table, nickel could go to a +2 or to a +3 charge. When there's that uncertainty, we need to deal with that in a specific way, which we will get to. So starting off with getting the chemical formula from the name, we need two things, both the element symbols and their charges. So sodium oxide is Na+. Oxide comes from oxygen, which is O2-. We cannot just call this NaO, because then if we take a look and we add up the charges, we have a +1 and a -2, which totals out to a -1. Every ionic compound has the charge totaling out to 0. So we need to accommodate that. In order to do that, we need to make the charges balanced. So if we look at this, I can have two sodiums, 2 +1s would balance off my -2. The shortcut to that is we take a look at the charges, and we do what's called the crisscross method. So the number of the charge, and not the sign of it, becomes the subscript on each element. Now we would never put a subscript of 1, so sodium oxide would be properly written as Na2O. Aluminum fluoride, take a look. Aluminum is Al3+. Fluoride comes from fluorine, F-. If we crisscross the charges, we will get Al1F3, but we don't put the 1, so AlF3. Calcium oxide, calcium is Ca2+, oxygen is O2-. Oops. Put that in the wrong spot. O2-. Crisscross the charges, and we would get Ca2O2. Now, contrary to what we did in Unit 5, when we cannot change the subscripts for balancing a chemical equation, when we're creating the chemical formula, we can. So calcium oxide would be properly written as CaO, since we can divide both of those subscripts by 2. Magnesium hydroxide. Hydroxide is not an element, it is actually a polyatomic, so we need to look at that chart above the periodic table to find it. Magnesium, however, Mg2+. Hydroxide is OH-. Crisscross the charges. Now, because OH is a polyatomic, and because OH is going to get a subscript, we need to show that that subscript of 2 applies to both the O and the H, so it's going to get brackets. So Mg bracket OH2. Sodium bicarbonate, this does not mean that we have 2 carbon atoms in this molecule. If we had 2, it would be di, and that would be a covalent compound. The other giveaway is this is bicarbonate. If we're going to have a compound made with just carbon, it would be carbide. So we do need to look up bicarbonate in that chart. Sodium, however, Na+. Bicarbonate might be difficult to find because it goes by 2 names. It goes by bicarbonate. It also goes by hydrogen carbonate. So once you find it, you'll see that it is HCO3-. Crisscross the charges. And each piece is getting a 1, so we don't need to put any subscripts. I also don't need to put HCO3 in brackets because it doesn't get a subscript. Calcium cyanide. Cyanide, even though it ends with an IDE, is a polyatomic, so we'll need to look up there to find it. Calcium, Ca2+. Cyanide is Cn-. Crisscross the charges. And we end up with Ca bracket Cn2. Now we jump to the place where we have an element that has multiple possible charges. That's copper. The way that that's shown in the name is with a Roman numeral in brackets after it. That Roman numeral actually tells us straight away what the charge on that copper is. So in G, copper we've been told is a +1. And that is the only way of knowing. Chloride came from chlorine, which is Cl-. Crisscross charges, each has a 1, so Cu, Cl. H, we have copper 2 chloride, so we've been told straight away that copper has a +2 charge. Chloride, again coming from chlorine, -1. Crisscrossing the charges, though, leads to a slightly different compound. That'll be CuCl2. In I, we have another element, that has multiple possible charges. That would be tin. We've been told straight away that it's a +2 by the 2 in Roman numerals. So tin, Sn, has a +2. Oxide came from oxygen, which is a -2. Crisscross. We would have SN2O2, but since we can reduce while we're doing that, we would have SNO. Tin 4 oxide, now we've been told that tin in this case has a +4 charge. Oxide, still coming from oxygen, still has a -2. crisscross, we would end up with SN2O4, but again, that's reducible to SNO2. Writing the name is actually a much easier proposition than writing the chemical formula. All we need to do is identify which two components make up the ionic compound and state their names. The only complication is when we have an element that has multiple possible charges, we do need to state which one it is. So copper 1 or copper 2, like in the last example. CaCl2 is made up of calcium and chlorine. Both only have a single charge, so the name, again, changing the ending of the last one to IDE, this would be calcium chloride. Na2O, sodium and oxygen, only one charge on each one, so sodium oxide. And again, with ionic compounds, we have no prefixes. We don't need them because everything has a specific charge. We can take care of it that way. ALN, aluminum and nitrogen, one possible charge on each, aluminum nitride. Fe2O3, the complication here is that iron does have multiple possible charges. We can look that up in the periodic chart of ions. So we need to figure out which charge it had. Was it +2 or was it +3? To do that, we can actually undo the crisscross. So the 3 as the subscript on oxygen would have come from the charge on iron. So that tells us that the charge on iron was 3, and this would be iron 3 oxide. NaClO, we would never name this with sodium chlorine oxide because it's an ionic compound. It has two names. We know we have sodium, Na, and ClO is a polyatomic by itself. So we need to go into the chart of ions, look up what the name of ClO is, and that's hypochlorite. F, again, we have an element with multiple possible charges, and this is a place where the crisscross undoing that we did in D breaks down. In order to figure out the charge on copper, we need to look at our SO4, or sulfate. SO4 as a charge has a -2. So in order to make that balance, the copper would have had to have a +2. This is like I and J on the last example, where we could actually reduce the subscripts later on. So that tells us that this copper had a +2 charge, and we have copper 2 sulfate. CuCl, like in D, copper having multiple possible charges. The subscript on Cl is a 1, tells us that the charge on copper was a 1, so we have copper 1 chloride. H, again, an element with multiple charges, that would be lead. Undoing the crisscross, the 2 would have been the charge on lead, so we have lead 2. We would not call this nitrogen oxide. NO3 is a polyatomic by itself. It is called nitrate. NH42CO3, now we have a compound made up of 2 polyatomics. The good news of polyatomics, they only have one possible charge, so we only need to find their names. NH4 is ammonium, and CO3 is carbonate. MgIO42. Mg is magnesium, only one possible charge. IO4 being a polyatomic, we need to go look that up. That's per iodate.